Dear all, welcome to Simplified Triple Studies. I will be discussing about the remaining part of uh, the answer key in the question paper of Basic Electrical Engineering. Let us start discussing question number 5a. Explain the operation of and construction of a DC generator. How do you give the answer? There are 8 marks. The 8 marks has been segmented into 2. If you write the operation of DC generator, credit you will be getting 4 marks. Then construction of DC generator you will be getting another 4 marks. Total 8 marks. Operation you try to add Faraday's laws of electromagnetic induction, and we can draw the schematic diagram like this. Okay. Then you can mention about Fleming's right hand thumb rule to identify the direction of thrust, the direction of magnetic field, and the direction of current. Construction you have to mention about field system, armature core, armature winding, commutator, importance of brushes with the relevant diagrams. Definitely you can able to get 8 out of 8. Now let us move on to another question. Another question is very important topic. I found many of the university question paper the same question had repeated. How back EMF regulate the armature current in DC motor? Explain the relevant equations. That's also quite simple. You need to understand what is back EMF. Write the significance of back EMF like this. You can underline the important points. Then you can mention about the equations. 2 equations you can mention. Possible diagram also. And you can say that without back EMF, the working of DC motor never be possible. There is a problem related to the generated EMF of a DC generator. So you need to know the basic equation first of all. Then you can make out very easily. Then lap winding and wave winding. In lap winding, the armature conductor parallel path, number of conductor per parallel path in case of lap winding, that is depending on number of poles. Where in case of wave winding, the parallel path will be 2. That point you have to remember. If you know that, definitely it is a dead DC. So you can use the given data, write down the given data and compute the value of EB. Okay, 2 cases you are supposed to calculate for lap winding and wave winding. So and you will be getting 6 marks, 3 plus 3. That's a division. In question number 6 you are supposed to explain the losses in transformer. What are the major losses in transformer? So you have to explain very clearly with the relevant points. For example, copper loss and core loss. Core loss has been divided into hysteresis loss and eddy current loss. If you can write with the equations, that is great. So total 8 marks credit you will be getting. Another question is related to the torque equation. Derive a torque equation of DC motor. So that you can make out. So you have to follow the torque equation. Draw the relevant diagram and mention the variables first of all. Then you have to segment the total derivation into 2 or 3 parts. Then you have to mention the PM, that means power developed. Then the power in armature you have to mention. Then based on the laws of energy conservation, then PM will be equal to the power in armature. Okay, so power in armature will be EB into IA. That will be equated to the PM, power developed. Then from this you can able to calculate TA by simplifying the equation. So you will be getting 0.1595 IA into PZ by a Newton meter. So definitely you can able to score full marks for this question. Very simple. And some cases there are numerical examples. You please take care of this equation. Question number 6C, that is basically an EMF equation of a transformer. You need to know the what is EMF equation and a transformation ratio. Then definitely you can able to do that. So please write down all the given data. Then I will show you how to solve this. So I have written the given data. These are the given data. Afterwards what I have done, so I have applied the equation of transformation ratio. E2 by E1 is equal to N2 by N1. Then from that I could able to get the value of N1. So N1 is equal to 2121 I have got. Then afterwards you can use the EMF equation. 4.44 FIM N. E2 also I am able to get. From this you can able to calculate the value of phi m, maximum flux. Okay, phi m will be 0.0233 Web. Kindly verify it. Then you have to calculate voltage induced per turn. Secondary voltage induced per turn. Secondary voltage is E2. Secondary EMF, secondary number of turns will be N2. E2 by N2 you are supposed to calculate 5.18 volt per turns. Then power rating of the transformer anyway it is 250 kVA. So from this you can able to make out one thing. So V1 is equal to E1 will be 11 kV or 11,000 volt. So you know that P is equal to E1 I1. From this you can able to calculate the primary current. So this is the way how to make out. And also you can able to calculate the secondary current. So that means E2 by E1 is equal to I1 by I2. From this you can able to compute the secondary current, that is equal to 602.21 amps. Please do verify it once. Question number 7 is related to induction motor. You have to explain about the rotating magnetic field concept. Let us go through. So if you want to explain the rotating concept or rotating magnetic field, you have to write the equation for flux at R and Y and B, like phi R, phi Y and phi B. Afterwards resultant flux, that is equal to phi R plus phi Y plus phi B. You have to prove that resultant flux is equal to 1.5 times of maximum flux. Definitely you will be getting what I can say, total 8 marks you will be getting. It's an easy question only, direct theory part. Draw the relevant diagram as well. So let us move on to the next question. The next question is very important topic, that is slip. What is a slip? Derive an expression for rotor frequency. So both are quite simple. Let us see how I have prepared the answer key. You are supposed to write the definition of slip with relevant mathematical equation like this. You will get 2 marks. Then you have to derive the expression for rotor frequency. For ultimately you should get f dash is equal to s into f, where s is the slip and f is the supply frequency, that you are expected to make out. If you know the particular slip equation, synchronous speed, how to calculate frequency, question number 7C can be easily computed. So you have to complete that particular answer. First you can able to write the given data like this. Afterwards you can compute the frequency, f is equal to Pn by 120. Remaining part you can able to calculate using the particular equation. Here the thing is, the alternator is supplying power to the induction motor. Alternator output is induction motor. Both are coupled actually. Okay, alternator, you know, it is a generator. It generates the electricity, and the induction motor, it consumes electricity. That's a correlation that you can understand. Similar kind of problem you have to work out. Let us look at the question number 8. So you have to explain about types of synchronous generator. So you have to, let us see how I have written the answer. Here you are supposed to explain salient pole type and non-salient pole type alternator with the relevant diagram and application. That you are expected to do. Definitely you will be getting 8 marks, 4 plus 4. 4 for salient pole type alternator, another 4 for non-salient type alternator. Like that you can plan. Question number 8B is a direct question. Develop the EMF equation of synchronous generator. First you have to define the parameter. Definitely you can go ahead with the derivation. So I will be showing you the final expression. So first of all you have to mention the parameters which is used in the derivation. Then you need to reach E average. Then frequency. You have to mention 2F from this expression. Then ultimately you have to calculate the average voltage. You know that form factor is nothing but RMS value divided by average value, that is equal to 1.11 in case of sinusoidal voltage, sinusoidal AC. So ultimately you will be getting the expression like 1.11 4 into F into 5 into T phase. Then if you consider pitch factor and distribution factor, that has to be added here. Ultimately this is your final expression, E is equal to 4.44 F 5 T phase Kp into Kd. This you are supposed to reach. Another question is related to the EMF equation of alternator. Anyway you have derived, definitely you can solve it. You are supposed to write on all the given data. Then you have to calculate the total number of conductors Z. Then phi is already given. Then frequency you are supposed to calculate. Afterwards you can use the formula, EMF equation. So phase voltage you will get. If you know the phase voltage, you can able to calculate the line voltage, because it's a star connected system. EL is equal to root 3 E phase. Please verify the answer. So far we have discussed up to question number 8. So I hope you understood how to answer it effectively, and try to add more diagrams and more equations, more analysis part, such that you can impress your answer sheets. So please practice it as many times as you can. So remaining question number 9 and 10 will be discussed in the next session. Anyway, thank you very much for watching this video and your kind support. I request everyone to share this video, those who are studying in the first year engineering background. Thank you so much for watching this video. Have a good day.